Welcome to the first podcast of AP Chem. We're going to start this podcast in Chapter 4. And in Chapter 4, it's mostly going to be about aqueous... Oops, sorry, I've got my eraser going. How about this? My aqueous solutions and types of reactions. You can see I've got a new highlighter tool here I'm playing with. So let's get right to it. The first thing you'll notice is some of these words. And here's a couple you know and maybe a couple you don't know. I'll highlight those. Now the first one, a solution, is something that you're very familiar with. Because if you remember, we did homogeneous mixtures last year. So we're talking about things like, milk, soda, and any kind of beverages that are clear. Let's think about lemonade, orange juice, those kinds of things. Those are homogeneous mixtures and those are solutions. If you can think about all of the chemicals you saw on the table last year with numbers like this, 1M, NaOH. Okay, when you saw things like that, that was a solution of sodium hydroxide. So solutions are made of two parts, and the first part is called the solute. That's this guy right here, and it's what gets dissolved. And so probably the best example, or the easiest example of that I can think of, is good old salt water. I don't know what that circle is, but we'll figure it out here eventually. And what this changes phase thing, all that means is that if you can imagine me dissolving some salt crystals in some water and stirring it up, you would get the salt going from solid to aqueous phase. So that's where it changes phase. The other part is, let's say I'm going to dissolve some methanol, CH3OH, into some water. Okay. Now the methanol, and in the case of the methanol, that would be considered the solute. So the thing that gets dissolved is the solute. The thing that does the dissolving, and for all practical purposes for us, for the most part, the solvent is going to be water. I mean, we're going to use water all the time. So water is almost always going to be our solvent. But basically, it's the thing that is present in greater amounts, and that's basically it. Now, soluble, you guys know that word from solubility rules. Ability rules, anyways. And so, if something is soluble, it can be dissolved. Now, let's move on and look at water for a second, because it is the most common solvent, and there's a bunch of points here that you already know. Water is a really good solvent because it's polar. And just as a quick review of last year, imagine we've got some hydrogen atoms over here. So these are hydrogens, as you know. Here's oxygen, right? And the hydrogen are a little less electronegative, so this is a more electropositive side. Oxygen has a greater electronegativity. And so you might remember the demo where I bent water last year, and that was possible because water is polar. So if you have things like this that are polar, it can dissolve things. Let me get back there. It can dissolve things that are also polar. And just last little part, if you guys remember from last year, we had that. We were talking about the angles here. The angle here between those is 104.5. I know my thing right there says 105, but anyways. So water's a really good solvent. So let's look at the next one. Hydration. Now that's the process of where water comes in and breaks up some ions. If you recall ions from last year, we just think about the model I have where I've got those little that little lattice there, where you've got positives. Oops, this would be a negative over here. Gotta apologize. This is the first time I've used this new pen, and I'm not a fan of it. Minus, there we go, and so on and so on. So you can imagine that if I take a water molecule and bring it near something like this, that the positive ends would be attracted to that, and the negative end of water would be attracted to that. And so what can happen is it can break up. And I've got just a little picture here, a very simple picture. And this is kind of what it looks like. So if you imagine, you can see this lattice work of positive and negatives. And so the positive H ends will line up with the negative ion, and the negative oxygen end will line up with the positive ions. And so that's how water is able to dissolve polar things. And as you can see right here, imagine this being an Na ion, oops, and positively charged, and then the oxygen's around it. So that's grabbing the ion and pulling it away. It does take energy, which is why a lot of times when dissolving occurs, your solution gets a little cooler. All right, so let's look at the next thing, the last little thing, and that is solubility. Now, you guys know from solubility rules last year exactly what's going on, so I just want to briefly touch on this. But basically, solubility is how much will dissolve in water. When we talked last year, we learned about the solubility rules, which of course we'll still be doing, but we were just worrying about it will dissolve or not. Well, in real life, it turns out that most things will dissolve to a certain degree, and that's kind of where we're going to go as this course continues. But basically, when we talk about solubility, we're talking about how much will dissolve. Usually it's how many grams, as you can see right here, per 100 milliliters of water. And it really depends upon the substance. And we'll get into that a little deeper later on. And this last little bullet right here, water can dissolve non-ionic compounds if they have polar bonds. So if you can think of something like, let's imagine something like a methanol molecule, an OH. Okay, if you were to draw that out, it would look something like this. And this is going to be a polar molecule. And so water can dissolve something like that. And where you have, if you have just methane, where you have H, that's nonpolar, and water can't dissolve that. So water can dissolve non-ionic compounds. All right. On to 4.2. Here's, again, a couple new terms. Electrolytes. Now, you know about electrolytes, of course, because you've been exposed to all those Gatorade commercials throughout the years. But electrolytes are just, for our purposes, are just solutions that conduct electricity. And I'm going to show you how well they conduct electricity in class with a simple little demo. But it turns out, and this was one of the things that we talked about last year, is that ionic compounds can only conduct electricity when they're dissolved in water or melted. Well, here's a situation where you have ions that are floating around, and so they can move. And because they can flow, it allows the charge, or the electrons, to jump basically from one ion to another. And in solids, when it's locked in a lattice, they can't do this. And so we classify electrolytes three different ways: strong electrolytes, weak, and non. And okay, so strong electrolytes. Now, the way we describe a strong electrolyte is something that will completely dissolve in water, or whatever kind of solution. Typically it's water. So if you were to look at all three of these things right here, whether it be the table salt, the nitric acid, or the sodium hydroxide, when those are dissolved in water, they're breaking up completely into ions. Okay, completely. NO3 minus, H plus. Okay, they're breaking up completely. And so that is what's considered a strong electrolyte. And strong electrolytes, by the way, one of their subcategories are strong acids. And these strong acids right here, you know what, I'll tell you what, since you're going to be writing these down, okay, these strong acids are the ones you need to memorize. Okay, memorize those. And as you guys know, I have a lot of little sayings to help you out. And this is how I've got this written out. You ready for this? Hibber, hickle, hi, hono, hickalo, hoso. Again, it's one of those silly things, but I'm telling you, it'll help you. You've got to memorize the 7 strong acids. And if you notice these right here, they're all halogens. And then, of course, you've been exposed to nitric acid and sulfuric acid. And then this is perchloric acid and chloric acid. All right. And then a strong base, anything with an OH is a strong base and therefore is a strong electrolyte. On to the weak electrolytes. And again, I'm going to show you a demo that will let you really see the difference when these things conduct. A weak electrolyte partially breaks up into ions. And so your book describes about how 1 in 10,000, this is acetic acid, will actually break up. Okay, and so what that means is that 1 out of 10,000 will break up into this, plus a good old acetate. Oops, H2. Boy, I am just rusty on this. I apologize for that writing. Okay, and so when we talk about weak electrolytes, we're talking about weak acids. We're talking about weak bases. And again, I'll show you exactly the difference between those. And then the last thing is non-electrolytes. And those don't break apart. And a non-electrolyte like sugar, remember when I dumped sugar into the conductive apparatus and the light bulb did not light? And that is because there are no ions for the charges, to flow. And so in a sugar, nothing happens. All right? Wow. Okay, this may be the worst writing I've ever done. So anyways, I appreciate your patience, and that's about it for this one. Jeez Louise, I cannot do this. And we'll see you next time. Again, any questions, just ask me about it.